Okay, so we want to figure out balancing chemical equations. So we look at this and it kind of looks like nonsense. So based on this periodic table, we'll try and pick out, which type of elements we're seeing here. So we have a capital letter. And notice that every letter here, they're all going to be capital letters, and if they end up with two letters, so if we look at GE versus C, now this is a capital letter, and this GE contains a capital letter and then a lowercase letter. So that's how you know that there's two separate elements here. So what that means is, looking at this first chemical, we see capital C, capital H. So what that means is we have capital C, but we're not going to go looking for a CH because they're both capitals. So that means they're two separate elements. However, these two separate elements can make a compound. Like water is made up of two different types. It's made up of H and an O. So anyways, back to the question right here. We have a C and an H. All right, so the next one. We have C and then a lowercase l. So this means that this is going to be just one single element. So we're going to look on the table for a Cl. Where might it be? It's right here. And then next, we have C, capital C, capital C, L. So that just means, again, this one's going to be a single one, and that one's going to be a single one. And then our last one here, capital H, capital C, L. So that's just to help you kind of recognize what we're looking for. So we'll go ahead and we'll just circle what we have on either side of the arrow. That's essentially what we want to look at in terms of balancing, right? So we'll just get this back up here. Balancing. That's what we're doing. We're balancing a chemical equation. So there we have our first equation. Now, balancing it, we mean we're going to cut this in half. We're going to look at what's on this side, and we're going to look at what's on this side. Now, as you see, there is a C on one side, C on the other. What's on one side has to match the other side. So, we have one C on this side. We have one C on that side. What do we have for Cl? Well, we have this little subscript means that there's 4 of just the Cl's. So we have 4 Cl's on this side, but we have only 2 on this side. How do we make it so that there are 4 Cl's on this side? What we can do is we can add a coefficient, that's what would be in front of the element, and that essentially multiplies this little number. So we have 2 of the Cl2. So if that looked like this, we have this, and then 2 of these would mean we have 4, right? 1, 2, 3, 4. And on this side, what it would look like is that. So we have 1 of those, but we have 4 of the actual elements. So that's all good. We balanced out that one. The last one to balance is H. So we have one H on this side, but we have 4 H's on this side. So we want to do this with the minimal amount of steps possible. So how do we make this 4 over here? We're going to put, obviously, the coefficient 4 in front of the H. Now, what this does to this one, the coefficient also does to this one. So then we have 4 CLs, which means we have to add, we'll just draw this in another color. So now we have 4 extra CLs, which means we are going to make this 8 CLs on this side. So we come back to this side, and how do we get 8? Well, an easy trick, we're just going to divide 8 by 2, and that will give us 4. And then we can change that to 8, and it's perfectly balanced. Right, because we are, again, just looking at it like this. We have, one of these. How do we get it so that we have 8? So we can count 8 of those. So anyway, we'll try this with the next one. Move that down. All right. Now, we look A and then a lowercase l. So that means it's just one element. And then obviously we're going to look what's on the other side of the arrow, because we know that we need to find an AL on the other side. What's on this side has to be on this side. So we see it's right here. And then we'll do our H's in orange right there. We can tell that it's a single element because capital letter comes next. So the H2 is right on that side. So there's 2 of them. Again, it'll look like this versus just a single H. That's what those little subscripts mean. And finally, our CL. So maybe we'll just start with we look here. Okay, what would be the easiest way to start? Because what if we add and then we have to change everything? Maybe we'll just look at what's the highest amount. Because what we do to this one, we'll have to do to this one. So we have 3 CLs on this side. Okay, so let's just balance that out. We'll do 3 there. Okay, then we go to the H's on this side. Okay, 2. Well, we can't put a 1.5. We have to put whole numbers. So we're going to have to change that. Maybe we'll have to multiply it by 2 just so that we can, 6, so that we can add a 2 in front of here. Okay, so that's a little bit confusing. What do we have here? So 2 times 3. That's going to give us 6 CLs. Oh, and what do we have on this side? We have 6 CLs. That's perfect. 6 H's, because the coefficient tells us we have to multiply both of the elements in our compound. So we have 6 H's. Now, how do we get 6 on this side? Right now we have 2. What do we have to multiply 2 by to get 6? 2 times what equals 6? Well, that's going to be 3. So we've got 6 H's on this side now. Lastly, what do we have to do to balance out our AL there? We look, okay, so this 2 is going to make it so that we have 2 AL, 2 aluminums, is what that actually stands for, but that's not important. We have 2, and we can easily just put a 2 there in front of our aluminum to balance it out. And so you can see on this side, we have 2 AL, 2 AL, 6 H's, 6 H's, 6 CL, 6 CL. Hopefully it's starting to look a little bit more clear. And the last one, okay, so now we have some new elements here. let's just look at the first one. So C and then a capital H. So we know that C, that's going to be a single one, single element. We got to look on the other side. What's on the other side? Find our C. It's right here. And we know that it's a single element because this is a capital letter. Next we'll do our O and an O there. Oh, but wait, we got another O here. Will that be tricky? Who knows? And then we just put the H's circled. All right, so what do we do to this compound? Well, maybe we'll look at this single O, because right now we have 3 oxygens. How are we going to make this 3? We can't. Maybe we'll start out by multiplying this by 2. Now we have 2 oxygens here plus our 2 oxygens there. So that equals 4 oxygens. And then on this side, 2 times what equals 4? I think we all know that one. It's going to be 2. And then we got 4 oxygens on this side. Let's see what else needs balancing. 4 H's. And ooh, that worked out perfectly. 2 times 2 equals 4. So we have 4 H's on this side. And lastly, our C's, we have 1 C here and 1 C over there. So it's perfectly balanced. And if we just get rid of all these boxes to make it a little easier to see, this is kind of what the actual balancing will look like. So that's what it looks like without all that, whoops. Looks like that without the extra noise. And obviously there's a nothing in front of this. We know that this means we want just one of these, but we don't have to put the 1 there. So we know that we want one of these compounds. So that's basically what you do to balance the reactions.